The lecture consists of 3 parts. First of all, the encoder part, second CNNs, and third, different architectures that use CNNs. And sorry for putting directly the slide here, I just want to refer to the image later. But so autoencoder, the intuition for an autoencoder is that it performs the identity matrix. And I mean, obviously we don't want to get why would we want to do like a fancy thing if we just want to get this thing out again, the same thing out again? Then why even apply a function? The reason is because we want to do different things with an autoencoder. So one thing could be image compression. So what happens inside the autoencoder is that we're going to massively reduce the spatial resolution of our input. So just imagine our input is image data. Image data by nature is like high spatial resolution and a dimensionality of 3, but high spatial resolution. And what we want is to shrink this to something small. And then if we unfold it, we want to get something that is as close as possible to the original. So here, this is my cat, and this is something that is supposed to be as close to my cat as possible. So that is the autoencoder. And why do we want to do this? So for 2 reasons. So either we can just take a bunch of input, for instance, cat pictures or cat and dog pictures, and then we just run it through an autoencoder that is going to shrink it somehow. We're going to talk about later how. And then it's going to unshrink it, so unfold it again. And here basically in the last version that our input gets shrinked to, because we have this target that ultimately we want to get the same picture out again, or as close as possible. This means that all of the relevant information for that picture needs to be encoded here in this small thing. So this means that this is like more processed already, like there is more information about what makes this picture unique. So for instance, we can then, but we can of course not keep every single information. So for instance, if we would have a human and we would want to reproduce the human, then we could, here encode what makes this human very distinct. Like, maybe the human has a big nose, or like green eyes, or certain kind of hair, blah, blah, blah. But we cannot, we can store important visual information, but we cannot store every single pimple that the person has. So what happens then if we put a picture of a human and then encode it and then decode it again? Then we will have the same human, but probably, all the important thing is still going to look the same, but probably it's going to look a little bit artificial, like in PCA, because we lost some of the variants. We lost some of, for instance, skin impurities, or maybe Carlos' hair is not going to be exactly original, but more kind of like it looks a little bit more computer generated, maybe. So that would be, and we possibly want to do this in case we want to have data denoising, because this thing here can only store the important stuff, and therefore this picture that we're going to get out is only going to include the important stuff. However, I guess PCA is better for denoising than autoencoders, but because my autoencoder worked terribly, but it's listed as a possibility. Then what we can also, sorry, it's already a little bit. Then we can, what we can also use the autoencoder for. So here in this last input, in the smallest input, we need to have all the information that is relevant to unfold the big picture, meaning that it is semantically charged. And the thing is, we do not have a certain aspect of what we are interested in semantically. So for instance, we can classify pictures like this. Is it a cat or is it not a cat? But we can just as well classify it. Is this picture illuminated or not illuminated? Or is this picture a fluffy cat or a hairless cat? We can, look at images or input in general from different semantic points of view. And the problem with autoencoders is we do not have anything that enforces that we look at the input under a certain perspective. But instead, we just discover the general structure, like the most prominent structure. So the most prominent structure needs to be encoded here. So the second reason why we can use autoencoders is if we do not have enough supervised data. So it's super difficult of the supervised data to learn something for a classifier such as a CNN to learn something if we have really little data. So we can make this as a pre-processing method, which means that just imagine we have very little supervised cat data, but we have a lot of unsupervised cat data, meaning pictures of cats and other things. So first of all, we train an autoencoder in its entirety, in the encoder and the decoder. So the objective is just to create something here that has minimal difference between this here. And then after we trained this, we're going to throw the decoder away and we're just going to use the encoder to give us semantically better embeddings, to just start at a better point. So basically now what we can do is to put the input through the encoder, and then we have the input but in an encoded version. And the advantage is the encoded version has less features, plus is already semantically charged in a way that is not super directly relevant to our specific target, but is in general relevant. And on this we can then add a few linear layers to make a classifier. So this is a pre-processing method. And now there are different types of autoencoders. So first of all, we have the denoising autoencoder. In the denoising autoencoder, we take an input, and the input is at the same time also the target. So we're going to train an autoencoder to have most little difference to the target. And now what we're going to do is we're going to corrupt the input data. We're just going to we're going to set some pixels to 0. And then the autoencoder does its thing, but then the target is still to have the uncorrupted version. So this means that the autoencoder gets trained in correcting a little bit like the impurities of nature. Then second, we have sparse autoencoders, and Schäfer said that he did not give actually a reason why we would want to do this, but a sparse autoencoder is one that adds a regularizer that pushes towards our weights to only be sparsely activated, to only cause sparse activations. Who knows? I don't know. And then there's the variational autoencoder, which is actually cool.